Hi, everybody. This is Mrs. Grisafi. We're on 10.03 Geometry Notes. We're going to talk about angles today in circles. And there's a lot of formulas that are involved in this unit. And we're going to focus just today on the angle formulas, but even for those, there's quite a few. And there's a lot of new vocab to focus on. So make sure you're really studying this vocab and understanding what they mean so that as we talk about angles that involve the vocab, you know what we're talking about. So first, we're just going to focus on some basic vocabulary. For example, when we talk about angles inside a circle, we want to be able to name them. So we want to look at where the vertex is. So here your vertex is at the center of the circle. So this one's called a central angle. And that means that its vertex is at the center. Here, and again, feel free to write down anything extra that you need in order to remember what these are. So this one is called an inscribed angle. Its vertex is on the circle, on the circumference of the circle, and it hits the circumference, each ray hits it again, that hits the circumference again, and this, between those two x's along that circumference right there, that is called your intercepted arc. And that occurs, intercepted arc. And that happens whenever you have an angle that hits the circle. It's the part of the circumference between those two marks, so between where the angle hits the circle. So it's kind of the part that's inside the angle, so kind of like that Pac-Man, right? It's what the Pac-Man is eating. It's this part right here, or the amount that his mouth opens up right there. So that is an inscribed angle, and it has an intercepted arc. Over here on the central angle, its intercepted arc would be from here to here. This one is just taking a triangle, and it's circumscribed about a triangle. So you can have inscribed or circumscribed. Circumscribed about a triangle. Okay, and so this is circle circumscribed about a triangle. And this one right here is called a chord. And a chord is just a segment that touches the circumference of the circle 2 times. So it's a segment as opposed to a line, and both endpoints must be on the circle. So if you're talking about a diameter is a type of chord. It's a special chord that passes through the center of your circle, but its endpoints are both on the circumference of the circle. This is a tangent to our circle, and a tangent is a line that hits the circle exactly once, so it just skims the circle right there. And this one is called a secant, and a secant line will cut through the circle, and it's a line, so it doesn't stop like a chord would, it continues outside of the circle, and that's a secant. So those are just kind of some basic terms that you guys need to know. So now we're going to talk about rules with these angles. So I was having a lot of trouble trying to write into this document. So I typed them in ahead of time because I couldn't write them for you as I was talking. So they're already filled in for you right here. So this is an inscribed angle. So when we name our angles, you're really looking at where your vertex is. So remember, to name an angle, you've got 3 points. This one right here, that's your vertex, where the 2 rays meet. That's called your vertex. So the vertex of this angle right here is on the circumference. So if it's on the circle, this is what kept happening. So I was underlining on, and it dropped. If it's on the circle, then it's going to be half its intercepted arc. So if you mark off where that angle hits the circle on the circumference, B would be its intercepted arc. So A, you can see that A is smaller than B. Now also don't get confused because we talked about arc length. Now arc length was finding the distance on the circumference. So that would be like if we had taken a string and put it along the arc and then took it away and tightened it and then put it against a ruler to see how many inches it was. That would be arc length. So you're talking in like inches, centimeters. Here we're talking about degrees. So our circle has 360 degrees. We want to know how many degrees it is from here to here. So A is definitely smaller than B. So remember, A is half of B. So an inscribed angle is half its intercepted arc. So A would equal 1/2 of B. The next one is a central angle. Its vertex is at the center of the circle. I like to say center, same, center, same, center, 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 same, because a central angle is the same as its intercepted arc. So the angle A right here is the same as its intercepted arc. So if I mark off where it hits the circle from here to here, that's the intercepted arc, and it would be the same. So if A was 30 degrees, then B would also be 30 degrees. Okay, sorry about the crying child. The next one is called a tangent secant or secant tangent angle. It's made up of a tangent line right here. So this would be a line touching this circle exactly one time. And I made my point too far over. So it hits right here. And then this one right here is a secant because it's cutting through the circle. So our secant and tangent meet at that point of tangency, and that vertex is on the circumference of the circle again. So it takes the same rule as our inscribed angle, which also had a vertex on the circle. So this one's going to be 1/2 our intercepted arc. A little tricky finding your intercepted arc here because we know it hits here, but it also, the other point where it hits is actually the vertex of the angle. So this red line right here, that's representing B, your intercepted arc. So angle A is equal to 1/2 of B again. Okay, the next one is if we have a vertex inside of the circle. So here it says it's a secant angle theorem, but also those could be made up of chords, which they appear to be chords in this particular picture as well. So this is when our vertex is inside the circle, but it's not at the center. So the center is O. This is not at the center. So it's not, the measure of the angle is not going to be the same as its intercepted arc. So you'll see here, if we're looking at angle A, it hits here and here on the circumference. So this B right here would be its intercepted arc. We know there's a vertical angle over here that would be the same as angle A. And that also has an intercepted arc. And that's going to be that red arc right there, which is C. So whenever the vertex is inside of the circle but not at the center, you're going to take half the sum of those two arcs. So the arc of the angle you're looking for and the arc of its vertical angle. Add them together, divide by 2. So it's half the sum of the intercepted arc. So 1A would equal 1/2 of B plus C. The next one, our vertex is outside the circle, angle A over here. If it's outside the circle, think about if you're an outsider, then maybe you're different than people. So think difference. So angle A is vertex outside the circle. It's going to be half the difference of the two arcs that it intercepts. So here, if we trace the sides of the angle, it hits here, it hits here, it hits here, and it hits here. So we've got arc B and you have arc C. So you're going to take the difference of those two, and you're always going to take the bigger minus the smaller. The bigger one's always going to be the second one you hit, the outside here. So we'd take 1/2 of C minus B to find that one. And the last one here, again, our vertex is outside, but instead of it being made from 2 secants, this one is made from 2 tangents, but it's the same idea. If it's outside, you're going to take half the difference. So you would take 1/2 of C minus B. So together, those two make up the entire circle, 360. So you're going to set A equal to 1/2 of C minus B. So in summary here, if your vertex is at the center, center, same, center, same, center, 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 same. Vertex at the center, the central angle is equal to its intercepted arc. They're the same. If the vertex is on the circle for an inscribed angle or a tangent chord angle or a tangent secant angle, then it's going to be half the intercepted arc. So at the center, same. On the circumference of the circle, half the intercepted arc. If it is inside the circle but not at the center, it's going to be half the sum. And if it's outside the circle, it's going to be half the difference. All right, so now let's go on and do a couple practice problems and put some of this stuff together. So this says measure of arc TC is 40 degrees. So I'm going to label that over here. Segment RC. So we were given something else I needed to give you here is circle O. We always name the circle by its center. So I'm telling you that O is the center of this circle. That means segment RC is a diameter, which also tells me that the measure of our arc RC is 180 degrees. Find X, Y, and Z. And there's a couple different ways you can go about this. First of all, we know that if segment RC is a diameter, then OC is a radius. OR is also a radius. A radius, remember, goes from the center of the circle to any point on the circle. So, and the radii are always equal to each other because it's always half the diameter. And the diameter is always that center line. It must cut through the center. So if OC is a radius, it must be equal to OR. And we have another radius at OT. So that one is also going to be the same. So now we've just created a couple of isosceles triangles. Okay, before we talk about those isosceles triangles, let's do something with this 40 degrees over here. So if this arc from T to C is 40 degrees, I can see, and if it helps you, try tracing an angle. So go from that X to a vertex. I should have done a different color here. Let's do red. And then go from this X to see where that goes. So they both meet right here. Now this vertex is at the center. If it's at the center, center, same, center, same, center, 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 same. So that's 40 degrees. Okay, well, if that's 40 degrees, then to find Y, those form a straight line. They're a linear pair. I can do 180 minus 40 gives me 140, which means Y is equal to 140 degrees. So that's 140. Now, I have a couple ways I could find X. One way is to say, well, if I trace from this X along this line this time instead of the red line, and instead of stopping at O, I go all the way to R, I now have an inscribed angle at angle TRC. So inscribed angles, the vertex is on the circle. It's going to be half its intercepted arc. So X would equal half of 40. So X must be 20. I now know that's 20, and I know this was an isosceles triangle right here. This black triangle is isosceles. So this angle up here must also be 20. They didn't ask us for that. Okay, now we also see this orange triangle right here is another isosceles triangle. So we know the vertex angle of it is 40. We know 3 angles in a triangle add to 180. So if I do 180 minus 40, that gives me 140. So I've used up 40 degrees out of the 180. I have 140 left. Since it's isosceles, and these are the two congruent sides, I know the angles across from them will also be equal. So I'm going to take 140 and divide that by 2, which will give me 70. So each base angle will be 70 degrees. So Z is equal to 70 degrees. Okay, so with these problems, it's really important, just start trying something. So instead, for this black triangle, you could have, once you found the 140, said 180 minus 140 gives me 40, and divide that by 2 to get the 220s. There's usually more than one way to solve these. All right, next one. The measure of arc AC to the measure of arc BC is in a ratio of 5 to 4. So whenever we see those ratios, put an x next to them. So AC is going to be 5x, BC 4x. Find the measure of angle AOC. So again, something I needed to give you here was this is circle O. So the center is O, which means segment AOB is a diameter. So from here to here is 180 degrees. So 5x plus 4x equals 180. And then you just solve for x. 9x equals 180, so x equals 20. And then substitute in, so the measure of angle AOC is equal to 5 times 20, or 100 degrees. All right, number 3, find the value of x, y, and z. So we're given here this angle is 20. I'm going to trace it. So you can see here it hits the circle here and here. So its intercepted arc is x. So if the vertex is on the circle, the arc is 2 times the angle, or the angle is half its intercepted arc. So to find x, we can do 2 times 20, which gives us 40 degrees. So x equals 40 degrees. Now again, like we did before, look at where this hits, and then instead of following those orange lines, I see other lines that are coming out of this x. I see one here, and I see another line here. So those 2 lines also make up angle Z. So Z's vertex is also on the circle. So it's also going to be half that intercepted arc. So Z is equal to half of 40, which is 20. So notice Z and the green and the orange angle are both inscribed angles that intercept the same arc. Anytime you have inscribed angles with the same arc, they're always going to be congruent or equal. Okay, so we know this one is 20. And that's a theorem. Inscribed angles that intercept the same arc are equal or congruent. All right, so now we have those are 20. We were also given this one is 75 over here. So let's trace that. Angle right here is 75, so it hits this circle here and here, which means this arc over here is double that. So 75 times 2 gives us 150. And now I notice I'm looking for y. Let's trace y. If I trace angle y, it hits the circle here and here. It has that same intercepted arc as 75. So y must also be 75 because it's another inscribed angle intercepting the same arc as the 75-degree angle. So that's our x, our y, and our z. Next one, find a, b, and y this time. So here we have a tangent chord angle right here at A. Whoops. Got a chord right here and a tangent. So it hits the circle here and here. Its intercepted arc is 110. So the vertex is on the circle. So to find A, we're going to take half of 110 degrees. So A is going to be 55 degrees. Over here on B, you also have a tangent chord angle. So the chord is that first red line I drew, and then here's your tangent. So it hits the circle here and here. Its intercepted arc is 170. So B is equal to half of 170. So it's going to be equal to 85. And then to find y, I see that they're all on that same tangent line. So all 3 of those angles add to 180. So I'm going to do 55 plus y plus 85 equals 180. And then you're going to solve for y. So add together your 55 and your 85, and then subtract that from 180. So you'd get 140, and then 180 minus 140 should give you 40 degrees. All right, now we're going to go through some more questions using these same rules. So at this point, hopefully you're starting to catch on to these rules. Try pausing it, try some of these. Maybe you want to wait for us to do 5 together since we haven't done one that's outside the angle yet, maybe 5 and 6. and then do the rest on your own. But see what you can do, give it a try, and then I'll go over them as well here. Okay, so number 5, I'm looking for x. So x is the arc from this point to this point right here. So I'm looking, they've given me an angle at 45 degrees that's outside the circle. So I know if I have an angle with the vertex outside the circle, it's equal to half the difference of our angle. So the angle is equal to half the difference. So 1/2 the difference, and we always take the larger minus the smaller, so x minus 90. Or if you want to write it like this, it might be easier for you, x minus 90 over 2. And then if you write it like that, you could put that over 1 and cross multiply. If you did it like the left-hand side, you could just multiply both sides by 2. Either way, we should get 90 equals x minus 90, add 90 over, and x is 180 degrees. Number 6, here's x, here's our center of our circle, but it's not forming an angle. The vertex is not the center, just passing through it. So the vertex is inside the circle, but not at the center. So that's going to be half the sum. So this one was half the difference. Here we're going to do half the sum. So x is equal to half of, and here's where it hits. We want that angle x and its vertical angle. So we're looking at these two arcs. Now, I don't know this arc up here, but I do know one over here is 110. And I know this is the center of my circle, so that makes this right here a diameter. So I could find this little gray arc up here by doing 180 minus 110, and that gives me 70. So now I know this is 1/2 of 70 plus 30, the sum of my arcs. So that's half of 100, which is 50 degrees. Number 7. So number 7, I've got 2 variables. First, looking at my y's, I notice that all of these y's make up the entire circle. So I could find y first. So I'm going to take y plus 5y plus y plus 2y. All of those y's together are going to equal 360 degrees. So add my like terms, I get 9y equals 360, divide by 9, and y is 40. So then it means this is 40, this is 80, this one's also 40, and this one's going to be 200. And I'm looking to find x now, because I already found y. So to find x, its vertex is outside the circle, so it's going to be half the difference. So I'm going to do x equals 1/2 the bigger arc, which is 200, minus my smaller arc, which is 80. So it hits here, that's the larger arc, and it hits here, and that's the smaller arc. Or you could do 200 minus 80 divided by 2, whichever way you want to. The way we're going to get 60 for x. All right, number 8. So maybe give this one a try on your own. If you haven't tried any yet, give it a pause and see if you can do number 8. Right, the vertex of this angle is outside the circle. So we're going to do 3x, so it's going to be half the difference. So 3x equals, it hits here, 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 and here. So this is our bigger arc. Our smaller arc is within here. So we're going to do half of 4x plus 50 minus 30. All right, so inside our parentheses over here, we can do 50 minus 30 to get 4x plus 20. And actually, let me write this one out, because I've been doing all the 1/2 in the front. But for many of you, I think it might be easier to think of it as over 2 instead of times 1/2. And then you can put this over 1 and cross multiply. If you had written it how I have it here first, just multiply both sides by 2. And many of you are fine with that as well. So we get 6x equals 4x plus 20. Subtract your 4x over, so we get 2x equals 20, and x equals 10. Whoops. Moving right along, I guess. The computer is forcing us to. Number 9, looking at that one, I see a vertex. Computer is not very cooperative today. I think it needs a reboot. Okay, so number 9. There we go. Vertex is outside the circle. It was formed by 2 tangents. So it hits, if a tangent only hits the circle one time, it's only hitting here and here. So the bigger arc is going to be, we call that the major arc. And then the minor arc would be between here. So it's all inside those lines. Okay, right where they hit on those X's is what's dividing it. So outsider is different. So we're going to take X, the angle is equal to 300 minus, well, what's this gray arc going to be? Together, they make a full circle. So I know a full circle has 360 degrees. 360 minus 300 would give us 60. So I know this right here is 60 degrees. So I'm going to do 300 minus 60 over 2, or times a half. Put your x over 1, cross multiply. We get 2x, or multiply both sides by 2. 300 minus 60 gives us 240. Divide both sides by 2, and x is 120. Or actually, this one, just as easy here. I'm not sure why I cross multiplied. You could have just said 240 divided by 2 right there and gotten the 120. I made it a little bit more complicated. Okay, number 10. 2 chords intersect within a circle to form an angle whose measure is 53 degrees. That's given to you right here. The intercepted arcs are represented by 3x plus 3 and 10x minus 14, which they're labeled. Find the measure of the larger of these 2 arcs. So let's set up our equation. We see an angle. Its vertex is inside the circle, but not at the center. So we should be thinking half the sum of the arcs. So the angle is equal to half the sum. So 53 degrees is equal to 3x plus 3 plus 10x minus 14 all over 2. Remember, it's the sum of its intercepted arc and the arc of its vertical angle. You have to add them both together. So here we can combine our like terms, and we get 13x minus 11 over 2. And here is where we might want to cross multiply because we have a variable over there. So we get 106 equals 13x minus 11. Add 11 over. You get 117 equals 13x. Divide by 13. And x is equal to 9. All right, number 11. So here I gave you one kind of, we call these the big circle problems because there's a bunch of things you want to be solving for in here. So here I've only given you 2, the measure of DFE and the measure of DGB. But honestly, I'm not going to worry about what I'm looking for right now. I'm just going to find whatever I possibly can find first and hope that that helps me. So I'm given here that this angle is 25. I'm going to start with that. Now this is an inscribed angle. Its vertex is on the circle, which means its arc is going to be 2 times the angle. So that tells me 25 times 2, this is going to be 50. So now I might be looking to say, okay, are there any other angles that intercept that same arc? Well, yes, if I trace from B and I trace from, I think that's an F, I have another inscribed angle. So that angle is also going to be 25, half of 50, or 2 inscribed angles that intercept the same arc are always going to be equal. All right, now I have been given this angle of 42 degrees over here, but I haven't used it yet. So I'm going to trace that just to see what's going on there. I know its vertex is outside the circle, so I'm thinking that angle would be equal to 1/2 the difference. It hits in these 4 spots in red. So 42 would be equal to this large arc out here, which I don't know. So let's call it x. I don't think we have used x in our problem at all yet. So it would be x minus 50 over 2. And we can cross multiply or multiply both sides by 2, get 84 equals x minus 50. Add your 50, and x is 134. Okay, did that help me at all? Well, let's see what angles also come to that 134. So here's 134 is from this black x to this black x. So if I trace this line right here and this line right here, they give me an inscribed angle. So I can take half of 134, which would give me 67. And I know this angle is 67. I have another inscribed angle of that same arc right here in this green one. So that would also be 67. All right, so let's see what we found and what we still need to find. So DFE is this black angle right here. So we have now found that the measure of DFE, I know I've covered up a lot of it, is 67 degrees. DGB is this gray angle right here. I've not found that yet. So in this angle, what I might want to do to find that, I have two options. I see a triangle right here. So I know I have 2 out of the 3 angles. I can use the fact that there's 180 degrees in a triangle. And I can do 67 plus 25 and then subtract that from 180. Or I could have said, oh, well, the vertex is inside the circle. Could call it Y, but it's not at the center. And then try to find my other 2 arcs right here to figure that out. Now that I haven't tried to do that method. I don't know if you have enough information to solve it that way. It looks like you wouldn't be able to find these 2 without knowing another theorem that we haven't talked about yet. So I think the triangles is going to be your best bet right here. So let's take 67 plus 25, subtract it from 180, and that's going to give me 88. So now the measure of angle DGB equals 88 degrees. And we've answered the 2 questions. And the last theorem we're going to talk about is if a quadrilateral is inscribed into a quadrilateral. So that means all 4 vertices are touching that circle. That means that your opposite angles, it's not a parallelogram, so opposite angles aren't congruent, they're actually going to be supplementary. So if you have something like number 12, you want to find x and y, you're looking for your opposite angles. So I know that x and 110 are opposite angles. In the quad, they're going to give me 180. And I know that y and 75 are opposite angles, so they're going to add to 180 as well. And then you just solve. So 180 minus 110 gives us 70 for x. And 180 minus 75 will give us 105 degrees. So if you have a quad that's inscribed into a circle, then the opposite angles are supplementary. All right, and that is it. I know this is a longer one and there's a lot going on, a lot of vocab, a lot of formulas, a lot of rules. So take your time with it, make sure you really understand and are memorizing those different rules that you need to use. All right, I hope you guys are all staying healthy and having fun. And I do hope to see you guys soon. Pi out.